This is the most popular and notorious lecture that I give in general chemistry. I've been advised not to put it on the web. Let me assure you that this is not an attempt to corrupt students or inspire any student to produce drugs, nor does it give them sophisticated enough skills to do so. It's humor, and students instinctively recognize it as such. It does, as I say at the end, provide useful information to those who aspire to careers in medicine or forensics. More importantly, it integrates topics from two different chapters in the general chemistry text to help students develop a skill that practicing organic chemists use on virtually a daily basis. I call this my subversive kindergarten teacher routine. Isn't this a pretty molecule? It's called cocaine. Cocaine is an organic molecule containing a nitrogen atom. Who remembers from the reading what that means? It means cocaine can act as a base. How do we know that? Well, in the Lewis structure, the nitrogen atom pretty much has to obey the octet rule, and we can see that the way we count electrons for the octet rule, it does have 8. And most atoms have a formal charge of 0, and we can see that the way we count electrons for formal charge, 1 for each bonding pair and both electrons in the lone pair, it has 5. And since it contributed 5 valence electrons to the Lewis structure, its formal charge is 0. Because it has that lone pair, it can accept a hydrogen ion or a proton from a strong acid, and that makes it a base. The nitrogen in the conjugate acid that results now has a formal charge of +1, but that's okay. We can write the equation like this, just abbreviating cocaine as CN. It's very easy to just use acid or base to interconvert the two forms of cocaine, the native or free base form and its conjugate acid. Hydrochloric acid is commonly used. When the conjugate acid is isolated as a neutral solid, it's often called the hydrochloride salt, or cocaine hydrochloride. So if you made the lifestyle choice to smoke cocaine, which would you prefer, the base or its conjugate acid? Oh, you would want the form with the higher vapor pressure, because smoking works by heating up and vaporizing volatile compounds, so you can breathe them into your lungs. So which form would have the higher vapor pressure? Well, the base form has no charge. It has no hydrogen atoms capable of hydrogen bonding, because no hydrogens are bonded to electronegative elements, just carbons. It does have some small bond dipoles, but it's so big and organic-y, it's pretty much nonpolar. So its intermolecular forces are just the weak London dispersion forces, or LDF. Whereas the conjugate acid is charged. It's a big polyatomic cation. So which form will have the higher vapor pressure? High vapor pressure correlates with weak intermolecular forces, so we would choose the so-called free base or crack cocaine. But suppose instead you made the lifestyle choice to inject or snort cocaine. Why not? Then you would want the form that is more soluble in water, because blood is an aqueous solution. Oh wait, blood is a colloid. Blood serum is an aqueous solution. So which form would be more soluble in water? The base, which is all organic-y, or the conjugate acid, which is ionic? Now you would want the conjugate acid, because it forms strong ion dipole bonds with water, so it will dissolve in water. So I hope this has helped you to become a more informed consumer of cocaine consumer products. Or if you want to become a doctor, nurse, forensic scientist, might help there too.
A little bit of ion here. A little bit of dipole there. A little bit of ion, dipole too. Some ion-induced dipolar glue. London dispersion everywhere. A boiling point's high, it's very queer. Oxygen, nitrogen, fluorine, so we say. Hydrogen bonding saves the day. Ah!